Hi, this is Ramya. I'm currently enrolled in wireless communication class, and I've taken my project title as speech encoding using linear predictive coding for data compression. What is speech encoding? Speech coding is a technique used for data compression of audio signals, that is in digital format. It uses a speech-specific parametric estimation and data compression algorithm combined together to produce the desired effect. The practical applications to mention some are mobile technologies, video conferencing, electronic toys, as well as numerous PC-based gaming and multimedia applications. This project proposes an efficient way of coding digital speech signal using linear predictive coding algorithm. In today's era of wireless communication, data rate is very important, and unless we find some way of coding large speed signal to transmit in fewer number of bits, cost of signal transmission is going to be very high. And this project implements a very simple way of reducing the number of bits that is being transmitted when a speed signal is used in wireless communication channel. So, what is speech encoding? Application of data compression of digital audio signal is called as speech encoding. It uses speech specific parametric estimation using audio signal processing to model speech signal combined with data compression. Why do we need speech coding? Preservation of pleasantness of speech along with low data rate. Low data rate is required because of the bandwidth. We cannot afford to infinite bandwidth to send the speech signal as such. Hence, it is going to be sampled and the data rate should be very low. It is needed as the bandwidth required depends on the number of data bits naturally. To transmit audio signal as is not possible, and hence it is digitized, compressed and sent. Current DSP processors are capable of more functionality and performance due to the development in VLSI and our own Moore's law. Let me give you an overview of speech encoding. Speech coding is a procedure of representing a digitized speech signal using as minimum number of bits as possible. It is important and fundamental to the operation of public switch telephone networks (PSTN) and also in modern day sophisticated digital systems like video conferencing, cellular communications, VoIP protocol, etc. The idea behind the algorithm is that the speech sample can be approximated as linear combination of past samples. Inside a signal frame, there are weights that are utilized for calculating the linear combinations and are obtained by minimized mean squared prediction error. The resultant weights are used in representation of that particular signal frame. The motivation behind speech coding is that because of digital communications evolution, the pressure on high bandwidth, lower error rate, and a better performance with a high quality of voice and intelligibility should also be considered here. Simple but efficient method of speech coding is done using linear predictive coding. Challenges in speech coding. There are a variety of challenges that a speech coding technique faces. Any audio signal that are encoded can be classified based on the bandwidth occupied by the signal source. The bandwidth occupied by narrowband telephone analog or signal is around 200 to 3400 Hz and the range is heavy. For any given source, the challenge is maintaining the average distortion in reproduced signal as small as possible given a lossy compression source. Since higher the bit rate, larger is the required bandwidth, our aim is to minimize the required rate so that the distortion is kept to a very minimal. The main objective of speech coding is to produce the output as close as to the original signal. Complexity is another thing that is to be considered when implementing a speech coding algorithm. The more the complex the algorithm is, the more the compute intensive will be the processor, and in today's DSP processor, the aim is to pack as much functionality as possible into a single chip. The following is a code snippet followed by this is a waveform of a given input analog signal and the output images of the signals in LPC compressed and voice excited LPC compressed signal. Now let me show you a demo of a speed signal algorithm. So basically I have a video, an audio signal and being fed as the input. So when I run it, this is the output of the signal and we can hear it as follows. The original signal is given here.
This was easy for me.
So this is a plain signal that is being recorded from the source, and then the LPC compressed signal is now played. If you notice, it is so much muffled and the data loss is heavy so that we cannot actually listen what is being said by the source. So an enhanced method, which is voice excited LPC compressed system, is used, which has a higher bitrate when compared to the LPC compressed sound, but then it is lower than the original sound and still maintains a better quality.
This was easy for me.
So the third sound is a better quality producing sound, which is really good and which is very efficient for us. Other methods of speech coding. So there are other methods of speech encoding. They are pulse code modulation, memoryless and adaptive coding, forward and backward adaptive quantization, adaptive transform coding, subband coding, etc. Pulse code modulation is the first waveform coding technique that was in practice since olden times. This has to do with quantization in both time domain and in amplitude. PCM is used both in public and fixed telephone communication system. Memoryless quantizers were in practice that provide maximum peak signal to noise ratio (SNR) for a given input value of power, or an SNR that is independent of input power. Forward and backward adapting quantizers are some that are designed to look ahead and look back respectively. The former looks ahead in time to get a step size value that is used for quantizing, whereas the latter collects the past samples for quantization. Adaptive transform coding are coders that derive input signal spectral representation and then using dynamic bit allocation to quantize the spectral coefficients. In the decoder side, the exact inverse is happening and the original speech signal is reconstructed. Subband coding is something where the wide range of audio signal is split into different subbands of smaller frequencies and wideband analysis is performed using filter bank approach, and each of the band signal is then mapped to a zero frequency domain and sampled at requisite rate. The parameters of to measure the quality of speech coders are as follows. To compare and contrast performances of any two speech coders, we need two parameters that we can use as a measure so that we can gauge the coder's quality. Here the word intelligibility refers to whether the output is clear, easily understandable, whereas the term quality is associated with how much natural to the original source the speech sounds to. In order to comprehend these two terms, certain parameters are defined. MOS, the mean opinion score, is a most intensively used parameter to measure speech quality and intelligibility. To find MOS of a speech coding system, end users are asked to listen to speech and describe its quality in one of the five buckets, rating from 1 to 5, 1 being very bad and 5 being excellent. The average is taken and the mean value is assigned as the MOS of the system. If the variance is large, then the measurement is unreliable. It doesn't sound what is true. AMBST, Enhanced Modified Bank Spectral Distance, is a measure that has high correlation with MOS. This measure relates to perceptually significant auditory attributes. The AMST values on an increasing note indicates increased order of distortion, a zero value being no distortion. DRT, Diagnostic Rhyme Test. This test is to test the intelligibility of the speech coders. This got the same name because the listeners are supposed to find which consonant is being pronounced when a pair of rhyming word is presented before them, say car and war. Each pair of words differs in one of the six attributes, viz. Nasality, voicing, sustention, sibilation, compactness, and graveness. Damn. Acceptability measure is a method to make speech measurement systematic, but to make best use of the system, it is highly important that the listener pool is highly trained in order to get any useful information and results from the test. PESQ, Perceptual Evaluation of Speech Quality, attempts not only to incorporate speech codes but also end-to-end network measurements. The E model, the final model attempts to weigh the mouth to ear quality of a communication line and is used to be best in network planning. This is termed modeled to quality loss due to delay signal. Conclusion: the current day speech coding techniques have become very effective due to advanced processing in DSP domains. Significant improvement in fundamental building blocks of speech coding methods are being developed. Current DSPs have really high computing power and to fully utilize the VLSI capability, but the computer architecture methods need to be devised so that a lot of computational capability can be used in digital signal processing techniques. Thanks a lot.